Let's talk about doing callouts from Apex where we are not using WSDL. So it's possible to access external web services where we're doing simple HTTP callouts without the associated infrastructure or requirements of WSDL or, for that matter, SOAP. There are some different things that are available to us in order to do this. In the case of doing a RESTful web service callout, we don't have those proxy classes to perform the parsing of the XML, but we do have classes like XML Stream Reader and XML Stream Writer, which allow us to do to manually or to do it ourselves in terms of parsing through those XML documents and pulling out the data values. There's also an encoding util and a crypto class for encoding, things like base64 encoding, and then encrypting and decrypting the content of our messages that we're sending out. So the encoding util class is some methods associated with base64 and URL encoding and decoding. We can use this for our message contents. There's also a crypto class which has methods for encrypting the contents of the data that we're sending or receiving. The web services that we are going to be utilizing are often referred to as RESTful web services. RESTful web services are simply web services in which we're doing XML over HTTP. In fact, it doesn't even necessarily need to be XML. We could just be doing, for instance, an HTTP GET. It uses standard HTTP callouts, things like GET and POST. But then also other HTTP verbs. The same security settings or same security requirements about doing callouts, whereby we must whitelist the sites that we're going to be doing these callouts to, is also associated with our RESTful callouts, in addition to our WSDL-based callouts. So here's an example of a RESTful callout using an HTTP GET. So all of the information that's being passed as a part of this request is a part of the URL. So if you think about something like some sort of mapping website, often they'll have query string parameters as a part of that, in which you can identify what the street address, what the city, state, so on and so forth, to be able to go out and request a maps for a specific site. Well, in this case, in this example, this is a web service, and what we're doing is we're verifying a United States address. And what we're going to do is we're going to pass it things like the street, city, state, and zip, and other information, in addition to the login credentials, things like our login ID and password, to be able to go out and make this request. But like I said, all of this is simply a part of the query string parameters. It's all part of our HTTP GET. Now, in order to perform this callout, what we're going to need to do is we're going to need to use the HTTP class, where we can send an HTTP request. The return for this is an HTTP response. Okay? We'll take a look at this in a second. That send method receives the HTTP request as its sole parameter, and then we get back our response. The HTTP request itself, there are a bunch of setters and getters associated with the HTTP request. What we're doing is we're identifying, well, what's the address? Are we doing a post or a get, for instance? If we're setting up the body of the message, we would do that. So all of this is associated with essentially creating that request or defining that request that's ultimately going to go out over the internet to the site that we're contacting. The HTTP response is what we're going to get back. And so if we requested, for instance, something that returns an XML document, we'd then be able to access the body of what we got back. We can also access things like HTTP status codes to see whether or not our callout succeeded or failed. There's the get body and then the XML get XML stream reader. These are similar, except what the get XML stream reader does is it returns the XML stream reader, which allows you to parse through an XML document. We'll come back to that in a second, but here's some sample code where we instantiated a new object based on the HTTP class. We created our HTTP request. We populated it with some of the criteria that make this specific request unique, like for instance, what's the URL, what's the method that we're using. Then we call the send method associated with our HTTP object, and ultimately we get back an HTTP response from doing that call out. Okay. So there's a couple of classes that are helpful in processing the results or building up our request if we're doing something like posting an XML document. So there's the writer and the reader for the XML streams. The XML stream reader, what we do is we iterate through an XML document, and we essentially go from event to event, which is a generic type of occurrence of something like a tag or an attribute within our document, and then from there we can pull out the different data that we got back. The stream writer, a little bit different, but here we're programmatically building up an XML document, and so we can start and end an element, add an attribute associated with that element, and then insert some data associated with that tag. All right, one of the topics associated with HTTP callouts is asynchronous apex, and the reason is that there's a requirement in the Force.com platform that if you're doing a callout from a trigger, you cannot do that callout synchronously. Now, it is okay to do a callout. For instance, let's say we called a visual force controller, and therefore the entry point to our code was our controller, and that's the context for the transaction. It is okay to do a synchronous callout and wait for the response from the external web service when it originates from a controller. But if it's from a trigger, we cannot wait for the response. We must execute the callout asynchronously. So let's talk about how we can create some code which runs asynchronously. So one thing to point out is that in the first day of the class, I mentioned the fact that we cannot create a thread and then start that thread and then do something on that separate thread. Well, the mechanism that we do something similar is we can use the future annotation associated with a method, and then upon calling that method, that will then run asynchronously. In other words, it will run on a separate thread. So anytime we don't necessarily only use asynchronous apex for the purpose of doing these web service callouts from triggers, but it is something that's required when we do have that use case. All right. Some limitations and considerations associated with executing asynchronous apex. You can do no more than 10 asynchronous executions per transaction. There's also a daily limit associated with the amount of asynchronous apex calls that you do. It's basically you take the number of licenses you have, multiply that by 200, and you cannot exceed that during a 24-hour period. Another thing is that when you create one of these methods, the parameters must be primitives. So you cannot pass objects over to these methods. So keep that in mind. One of the things that you'll see is that passing something like a record ID and then performing a lookup to actually reconstitute the object. All right. So here's an example of a bit of asynchronous code. In this case, this might, as you can see, it's constructing the HTTP request. So later on, we might be actually doing that HTTP callout. Now, in addition to annotating the method with future. We also need to set up this property callout equals true. So anytime we have asynchronous code that is doing a web service callout and being called from a trigger, apply to the method that is the asynchronous method the future annotation, and then do the parenthesis callout equals true, and then the end parentheses. Okay. So just a requirement associated with doing those callouts from a trigger. Now there's another aspect to this which I want to mention associated with our governor limits. And so there's a side consideration or an effect when you run asynchronous code. And that is when you run asynchronous Apex code, it starts a new governor limit transaction context. Okay? So for instance, if you are executing some queries, and let's say that the entry point was our trigger, well then we're limited by the 20 is the ceiling for which the number of queries we can do. If we then execute some asynchronous Apex, the code that's running asynchronously will have its own governor limit context, and then therefore those will be reset. Okay. So keep that in mind. It's a just a kind of a side note to running asynchronous Apex is that it does restart those. All right, let me introduce the lab exercise, and then maybe later we'll or after this we'll take some questions. So in this lab exercise, what we're going to do is we're going to create a trigger, and the purpose of this trigger is to do a callout. Therefore, what we're going to do is we're going to create a method which is asynchronous. What this is going to do is, so our trigger will call the class which contains the asynchronous method. This is very similar to, or it's once again associated with our candidate information. What we're going to do is we're going to check to see if the address needs to be validated. If it does, we're then going to do that call out to a web service whereby we're going to check to see that the address fields are actually a valid US address. We're going to get back a response basically indicating yes or no that this is a valid US address. Because the code is running asynchronously, what's going to happen is that when we make the original update to the candidate record, that'll execute the trigger and we'll immediately save the record. But later on, once we get our response back from our web service callout on our separate thread, it will then update that candidate record that we just previously had updated, and then update it with by marking whether or not this is a valid US address. Now, one of the things that we can do is that, or one of the pieces of our logic is that we only do this callout when necessary. So by marking the candidate record with a checkbox, in other words a Boolean, we only do the callout when necessary. Okay. Another aspect that affects the way that when you're performing this, when you're doing this lab, is that when you're testing out your code that you create, you're going to click on the save button. It'll execute the trigger. The record will immediately be saved, and it'll take you to the view page for that record. You're going to need to wait a few seconds and then refresh that view page to see the result of the asynchronous callout. So keep that in mind. The asynchronous callout, our trigger does not wait for the response. It immediately executes, and you'll have to refresh that page to see whether or not it's a valid address. But the asynchronous code, like I said, will be updating the database later on. Another side note to the asynchronous methods, they don't return anything, obviously, because we're not waiting for anything back from those callouts. Okay. All right. Finally, one last thing to mention about the way we've designed this lab. There's some custom error handling that we're doing. And so one of the things, if we remember back to when yesterday we were talking about our debug logs, the debug logs, only store the last 20 items that you requested or that it stored. In addition, keep in mind that your debug logs are not by default capturing live data. You need to churn on the log request before you'll see anything. So one of the things that we've done is we've created a custom object called error log. And anytime we get some sort of error, perhaps we're always doing this, we insert a record of object type error log in which we store information about whether or not this succeeded or failed. Okay? So this is something you can do within your applications, which is if you want to, for instance, have an always on logging mechanism, you can always communicate to the outside world or send an email. So there's a number of different things you can do. But one of them, which we're doing here, is that we can use our database, create a custom object for the purpose of logging, and then write whatever messages we want to the database. Now, there's an important consideration when we're using custom error logs, which is, remember when we were talking about the nature of committing data to the database when we do not have, when our code does not complete successfully. So this is only going to work when we catch the appropriate, or when we catch our exceptions. If we had an uncaught exception, that would mean that none of our data would be committed to the database. That means that our error log, even though we are writing it to the database, it would not ultimately be written to the database or committed to the database. So this only works in the context of exceptions that you're catching. If there is an uncaught exception, the error log will not appear. So keep that in mind when you're writing your code. Okay. All right, so why don't we open up the floor to questions about our RESTful callouts and asynchronous Apex or anything else? David, yes.
It says that getters and setters, you can't use the future annotation. What makes it a getter or a setter? Is that, does it use the, look at the code, or does it use the method signature?
Let's see. So the future annotation cannot be used in getter or setter methods or constructors of visual force controllers. They're not. There's nothing special per se about the way that we identify in a visual force controller. There's nothing special per se about when we create a getter or setter in terms of the actual syntax and the code. What is different about your controllers is that they're being called from visual force pages, and there's some sort of container type of mechanism in between the visual force page request and then the call to the getter and the setter. So with respect to this last bullet where it says the future annotation can't be used in those getter or setter methods or constructors, I assume this has something to do not necessarily with sort of a compile time check per se, but a restriction associated with the actual runtime call of the visual force page to requesting whatever the method is within the visual force controller. Because a visual force controller is simply just a class. There's nothing that you do to necessarily identify it as a visual force controller.
Okay, I wasn't clear that the getter setter applied to visual force controllers. That sentence was, if we're just constructors of visual force controllers and getter setters in general.
Oh, okay, I see what you're saying. So the future annotation cannot be used in getter or setter methods or constructors of visual force. Yeah, I read it the other way. Oh, okay, all right. No, I think this bullet is referring to specifically to visual force controllers, which have, like I said, there's some sort of web container that's ultimately calling these methods. I would imagine this is a runtime type of check that's occurring as opposed to a compile time. So, yeah. Okay, another question in the back.
It seems like the 200 future method calls per Salesforce license in a 24-hour period makes it kind of impractical for any kind of audit or edit that would need to occur frequently. So it seems like you have to reserve what you use these for.
It's 200. So it's 200 per license. So if you had 1,000, so we're talking about 200,000 per day or per 24-hour period. But you're saying if you had a frequently used application, you might hit that. Is that?
I'm not quite sure.
Yeah.
It seems like it might be. I mean, if you were doing something that was like say a call center application, it's easily possible your users are doing more than 200 of an event during a day, and if that event was doing futures, you could exhaust this. That's all I was just saying.
Yeah. I mean, I'm not. Perhaps. It is a total number, so. It is one of those things that's associated with the org as opposed to. Let me look up the fact. It's my understanding that this refers to that 200,000 number is applied at an org level. It's not a 200 per user type of. The per user is simply in the math calculation in terms of calculating the total number. It is based on it is an org. I believe it's an org-wide number as opposed to a per-user number. I mean, I could see how this, if it's a specific user having a busy day, it may be something you run into. Yeah. Unfortunately, I don't have any sort of anecdotal evidence of people hitting this ceiling.
In a way, it's similar to our other execution limits of times and other things, because these basically queue up. I assume these go to some asynchronous batch queue or something, and they get run in some order. Yeah.
And asynchronous callouts, there's no, a side note to asynchronous callouts is that, just asynchronous code in general, is that there's no sort of guarantee as to when it runs. So there is a queue behind the scenes. In fact, we can actually monitor that queue by going down to monitoring Apex jobs and see our asynchronous threads. But there is no guarantee in terms of when that executes. Let me look up just to get make sure that that's an org-wide number that's applied as opposed to just a per-user number.
That would make it a lot better for people, obviously.
Yeah. Okay. Any other questions? Yes.
Depending on the no guarantee for when it runs.
Yeah.
Are there any guarantee on the order they run? Like say, I do I call a future function, and then I call a different future function. Do I know the first future function I call always executes for me?
Yeah, I don't think so, but let me take a look at that. Let me try and find that out for sure. I'll take a look at those too.
I was recently talking to the team, I think, that implemented that, and it's not. I think it would be very hard to guarantee the order.
It's not ordered. Okay.
Because the batches can be being run on multiple servers.
And
the same kind of message type can go to multiple servers. So I think guaranteeing order would be difficult.
Okay. All right. Well, then we have we're also getting it up here from Deepa. So there's not a guaranteed order in terms of the execution of those. They could be executing on different servers independently. So yeah.
Another follow-up on that. If they call out from a trigger to update the database, will that always be executed after the trigger transaction is committed? If it's a insert, we don't even have the record.
Yeah. That's a good point. Once again, I don't know if there's necessarily. It does seem conceivable that the original thread would not complete and do that commit before the asynchronous. I think there's no sort of within Apex, there's no concept of sort of a sleep that you could put on your code. There's not a way I could really test that, but I guess it does seem conceivable, but it also seems like something that is also something that would rarely happen. I'll take a look to see if I can find if the docs mention that, but that might be kind of a fringe case that I don't know if there's necessarily a definitive answer out there. So.
Related to that, if the trigger later fails, is the future still run? In other words, you send the future, the trigger later fails. That would be, I think that would tie the two together, because if the future only runs if the trigger succeeds, then you almost have your answer, because they can't really commit it to the queue until the trigger completes. So, and I could see both ways. I don't know which way it's implemented.
Yeah, yeah. All right, let me try and do a little research on the execution. I think one thing that's related to this is the fact that they are treated as two separate transactions. So to me, that indicates a sort of a fire and forget type of execution. But let me see if I can get some more details on that. Okay. Okay, I'd like to continue by following up on our module review and just go through some of our review questions. And then what we'll do is we will start in on our email services. So let's see here. Who can I pick on? I think the last time we asked a question, it was yesterday afternoon. So do I have any brave volunteers for taking a review question? And it says, is it necessary to import a WSDL to perform a callout? So, all right, we have a volunteer, Pratima. So, no. All right, I'm taking that as a no to the question, not a no to do we have a volunteer? So, all right. Fantastic. So the answer is yes, or I'm sorry, is no. We do not need to import a WSDL. So an example of a non-WSDL based web service is when we're doing a RESTful web service callout. Okay. So Rajna, you're up next. Which classes are used to send an HTTP callout and receive a request? And specifically, there are three of those classes. Very good. So HTTP request and HTTP response, and then there's a third class, which HTTP. So we use the HTTP class to call the send method. Okay. Dan, if we want to make a call out from a trigger, how do we do that? What is the necessary thing that we must do?
Is that where you have to do the call equals true on the method signature?
Yes, and that is associated with what? So we have to do the call equals true. What else? What is that associated with? Yeah, exactly. So the future annotation. So in order to do that call out from our trigger, we need to call a method that is annotated with future, and then also set call out equal to true. Okay. Setting call out equal to false, by the way, will prevent that code from actually doing a web service call out. So, Peter, how do you create your own transactional web service method? So if we, and by this we're referring to within the context, inside the web service method, how could we do a transactional one? Anyone have any suggestions or ideas? Yeah, exactly. Okay, so save points and rollbacks. Well, one of the things we can do inside of the method that is the web service is to use things like save points and rollbacks. And so, maybe we're going to insert two different objects, two different DML operations. Therefore, we could combine them into a single unit of work using our save points and our rollbacks. Okay, explain the HTTP callout timeout limit. So, Dipti? Very good, very good. So there's each individual one, there's a maximum of 60 seconds, and in sum, a single transaction can do 10 callouts, and the total timeout would be 120 seconds. And then Sharondeep, the final question, when do asynchronous methods execute? That's correct. So you are not sure. So you never know. So so you don't know. So whenever, we don't know.
For more information on Salesforce.com training and certification, please visit www.salesforce.com/training.